for the second day on Chapter 10, Section 3, Operations with Radical Expressions. Let's take a look at our first problem here. And here what we're doing is we are trying to rationalize the denominator. We're going to simplify the quotient. And so what we're going to end up doing is multiplying by a number to cancel out the square root of 11 and the square root of 7. So what we're going to multiply by is what's called a conjugate. And a conjugate is just the same numbers but a sum or a difference. And so in this case, I'm going to multiply, to make a conjugate, I'm going to multiply by a sum. See, I already have a difference, and if I go ahead and multiply it, it's like a difference of squares. And it makes a perfect square when I multiply the square root of 11 by the square root of 11, because those are the same numbers. Here, this is a square root of 7 and a square root of 7, which makes square root of 49, which will end up making just 7. And so I'll do the same thing on top to keep this all in balance, because I want to keep it the same expression. I just want to multiply by a factor of 1, and that's what I have right here. So in the numerator, I end up getting this. I get 12 square roots of 11 plus 12 square roots of 7. But in the denominator, when I go ahead and multiply, again, 11 times 11 is 121, but the square root of 121 is just 11. And then notice that the outside terms and the inside terms are exactly the same but opposite in sign. That's why we multiply by the conjugate. And that will end up canceling each other out. And so all I'm left with then is the square root of 7 times the square root of 7, which is 49, which just makes 7. So it's going to be a minus because we've got one negative in this problem. And then all I have to do is subtract these two numbers. So I end up getting 12 square roots of 11 plus 12 square roots of 7 all over 3. Actually 4 in this case. So let's take a look at the next problem. And when we go ahead and multiply here, I'm going to multiply by a conjugate that's going to cancel out the square root of 3 and the 1. And in this case, I'm not going to cancel out the 1, but I don't want to have a radical at all in there, so I'm going to multiply by a conjugate. And I'll do the same thing on top to keep it all in balance, to keep it 1. And I'm left with this. I'm left with 8 square roots of 3 minus 8. And then down below, I've got the square root of 9. And then I go ahead and take that square root of 9, gives me 3. But notice that the outside and inside terms are going to cancel out because they are the same number but opposite in sign. 1 times negative 1 just makes a negative 1. So I'm left with this, 8 square roots of 3 minus 8 all over 2. Now as I was looking back at these two problems, as I was doing this one, I see I could have reduced this, and that's what they want us to do here. And notice I'll be able to reduce this one as well. And the reason why is because both of these two factors, these two right here, both have a common factor of 4. See, 4 goes into 12, and 4 goes into this 12. And since it goes into both, I'll be able to reduce it. See, if I rewrote this as two separate fractions, it would look like this. And 4 goes into 12 3 times, so I got 3 square roots of 11. And 4 goes into 12 3 times, so 3 square roots of 7. So that is the simplified form there. So on this one, same sort of thing. 2 goes into 8, so that's going to be 4 square roots of 3. And 2 goes into this 8 here, which just makes a minus 4. Cannot combine these because I've got the radical of 3 I have to multiply first, and this one does not have that radical of 3. So in this one, I'm going to multiply by the conjugate. It's going to be the square root of 7 plus, so let me put that plus sign in there, plus the square root of 3. You can do that on the top and the bottom of the fraction to keep it as just a factor of 1, and I multiply across. I've got 32 square roots of 7 plus 32 square roots of 3. So looking at the denominator, the square root of 7 times the square root of 7 makes 7. Square root of 3 times the square root of 3, well, that's going to make 3, but a minus sign because 1 negative. Again, the outside and the inside terms are canceling out. That's why we'd use the conjugate. And so I'm left with this, 32 square roots of 7 plus 32 square roots of 3. And this is all over 4. Well, 4 goes into both these terms, so our answer is 8 square roots of 7 plus 8 square roots of 3. So moving on to the next problem, we're going to end up seeing a couple word problems. And on this first one, it says that we're supposed to find the length of the hypotenuse of the right triangle. And so there's the right triangle. This is the hypotenuse, always opposite the right angle. We're supposed to write our answer in simplified radical form. So the form to come up with the answer for the hypotenuse, I'm going to use the Pythagorean theorem, which says I square the leg plus the square of the other leg is going to end up giving me the square of the hypotenuse. And so this is going to equal x squared. And so when I go ahead and square this, this is going to end up making the square root. Now again, I'll write this out twice so you can see it. So I have the square root of 5 minus the square root of 2 times the square root of 5 minus the square root of 2. So it's not a difference of squares here. So it's not going to make 5 minus 2. It's not going to make that this time. It's going to make 5 for the first term, because the square root of 5 times the square root of 5 makes the square root of 25, which is just 5. But the outside terms and the inside are not canceling. They make negative square roots of 10 and negative square roots of 10, which don't cancel either. They are the same sign, so you're going to end up adding. So on the last term, though, it does make a positive 2, because it's the square root of 4, it just makes 2. So our answer here is 7 square roots, actually 7 minus the 2 square roots of 10. So this is negative 1 plus negative 1 makes negative 2. And so I have to add on this next one here. And so this one is going to end up being, again, the square root of 5 plus the square root of 2 times the square root of 5 plus the square root of 2. And we end up with 5 plus, and this is a square root of 10, and another square root of 10 for the inside terms, and then a positive 2. So that makes 7 plus 2 square roots of 10. 2 because it's 1 square root of 10, 1 square root of 10 make 2 square roots of 10. So I'm supposed to add these together, and they'll equal x squared. And so when I go ahead and add these, the 7 and the 7, those are the same signs, so that makes 14. And then here I have negative 2 square roots of 10, negative 2 square roots of 10, which just makes 0. These two terms will cancel out, these two terms, because they're opposite in sign. So I'm just left with 14. And it doesn't give me the units, so I'm just going to write down 14 units equals x. And it equals x squared. So I'm going to go ahead and take the square root of both sides, and that's going to give me my answer. The square root of 14 units equals just x. So on this next one, all we had to do is leave it in radical form there. On this next one, it says that the large park is designed as two 10-kilometer square connected at a corner with the diagonals aligned. If Riley jogs along the diagonal from one end of the park to the other end, how many total kilometers will he jog? So from this end all the way down to this end here. We're supposed to give our answer in simplified radical form and to the nearest tenth. So what I'll do is I'll make a right triangle out of this. And so I just about see it. If they just had filled in this little part, I would have had it. So this is 10, this is 10, so this side is 20 kilometers. And then on this other one is 10 and 10 make another 20 kilometers. And so I'm going to do 20 squared plus 20 squared equals the jogging path squared. I'll go j squared. So this makes 400 plus 400 equals the jogging path squared. So it makes 800 equals the jogging path squared. So when I take the square root, well, I see 8 times by 100 makes 800, and 8 can break down to 4 times 2 times by 100. And so I'll go ahead and take the square root of 4 and the square root of 100, make 2 and 10 respectively, and I still have that square root of 2 underneath the radical sign. And so once I go ahead and take that square root, again, taking the square root of j squared, so that just leaves me with j. So now I've got 20 square roots of 2. And these are in kilometers. And so that's the simplified radical form. And now we're going to find out what the approximate is, in the decimal form rounded to the tenths. So I'll go ahead and enter 20 times by the square root of 2. And I'll press equals, and there it is, 28.3 is what this would round to. The 8's big enough to round the 2 up. So 28.3 kilometers, 28.3 tenths is the length. So those are the types of problems you're going to see on tonight's homework. Good luck.